So this is the Google Foundation course, and this is the module. 1 minute. This is the module 5. Let's get started. Okay, so the objectives of this particular session is overview of GCP storage services, cloud storage, persistent disk, and cloud file store. And we'll also have a hands-on demo of how to store data in cloud storage, and then use cases of storage services. So these are the learning objectives or the agenda of this particular module. So let's take a deep dive on GCP storage services. Storage, the reason why storage is important in any cloud platform is storage services add persistence and durability to application. For example, any application to be persistent and durable, you need to have a strong GCP storage service. Storage services are classified into three types broadly, and in detail 4 types. Versus object storage, block storage, file system, and cache storage. So let me explain you what exactly is each of this storage types, because unless and until you understand each of the storage types, it's very difficult for you to understand, to probably apply things in context. So when it comes to object, what is an object storage? Here all the data will be stored as objects, either as files or folders. Any unstructured data like image file, video file, text file, and HTML files can be stored to object storage. Block storage is where you install your VM or your database. Usually the block storage in GCP is the persistent disk that you attach to GCE. File system is how you organize data into different files and folders. And cache is an in-memory data store designed to provide application with sub-millisecond access to data. Its primary advantage over other storage systems is its low latency, because it gets cached for the first user, and for the following user the latency will be drastically reduced, because it will be retrieving from the cached storage, not from the server storage. So caches are limited in size by the amount of memory available, and if machine hosting the cache shuts down, then the contents of the caches are lost. These are significant limitations, but in some use cases the benefits of fast access to data outweigh the disadvantages. GCP also has a lot of other storage services, including a managed Redis cache service for caching, persistent disk storage for use with VMs. In other words, that's the block storage for GCP, and object storage for shared access to files across resources. Archival storage, basically for long-term and infrequent access requirements. So, Google's cloud storage as an unified object storage for a variety of applications. Applications can store and retrieve objects through single API, that is Google Cloud Storage API. GCS can scale to exabytes of data. GCS is designed for 99.99999% durability. This means there is null data loss. GCS can be used to store high frequency and low frequency access of data. Data can be stored either in single region, dual region, and multi-region. And also the most important aspect of Google storage is its storage classes, and this is a very important topic. In any certification you take up, there will at least be 4 to 5 questions on this particular type. There are basically 3 storage classes in GCP. The first is standard storage class and nearline and cold line. First is standard, nearline and cold line. Standard is used for high performance object storage, and these two are basically used for backup and archival. So these two, the use case of these two is backup and archival. But most common storage classes used by developers optimized for reduced latency. Standard is if you have to retrieve daily or quite frequently with high performance, then this is advised. And for backup and archival, you have two storage classes, that is nearline and cold line. And again, for nearline, you have low frequency access, and cold line, you have the lowest frequency access. Nearline, it's meant for data accessed less frequently, for about a month or month and a half, chosen for data that should be accessed once less than a month. When it comes to cold line, it's meant for data accessed least frequently. That is, cold line is basically for archival, archiving the data of years, accessed less than a year. So now the most important aspect is Google Cloud Storage location type. You have three location types. First was storage type, second was storage class, and now is location type. Where do you put your data? What are the different location types available for storing your data? There are three types. First is just regional, second is multi-regional, and third is dual regional. That's again totally dependent on application and your customer base. Let's concentrate on regional. Your data is stored in a specific region with replication across availability zones in that region. Good for co-locating compute and storage for high performance. Dual region, your data is replicated across a specific pair of regions. Good for when you need co-located compute and storage and automatic failover. Multi-region, your data is distributed redundantly across US, EU or Asia. Good for serving content to end users when you want automatic failover. Suppose the use case of all these three is when you have to choose multi-region. Multi-region is when something happens. You want your whole data to be safely switched to another location and you want it to be redundant, then go ahead with multi-region. And regional, your data is stored in a specific region with replications across different availability zones in that region. Good for co-locating compute and storage for high performance. If you want to look for performance, choose regional. If you want data to be backed up in two or different regions, and if the data is if the data gets completely wiped out due to a natural calamity, then it's always advisable to choose multi-regional. Third, dual regional. Your data is replicated across a specific pair of regions. For example, one in Asia South, that is Mumbai, and the other is US East one. It's branched out into two dual regions. Good when you need co-located compute and storage and automatic failover. So you'll have to also understand, see, as you become a cloud architect, it's not just about knowing things, it's about knowing things and also having a sound judgment of what needs to be used. Another type of storage type that's used. Okay, before getting into persistent disks, I already explained you there are four types of storage types. First is object storage to store objects. Second is block storage to install your database or install your VMs. Third is cache storage. And fourth is file system storage. So before taking a deep dive to persistent disk, I want someone to tell me to which storage type does persistent disks fall into.
Block storage or the object storage?
No. How can this be object storage? See, you have couple of documents, right? You have images, you have few movies, you have few TV shows, right? You have few HTML files. Those are called objects. Any text, image, object, audio, HTML file. right? Persistent disk is a disk that you attach to a VM. Why do you attach? Because on a VM you install OS, you install CPU, right? For all that, VM also needs some memory, right? That is called persistent. This falls into block storage. I repeat, block storage. You can also add extra persistent disk and install Oracle DB or NoSQL DB or a PostgreDB, right? So persistent disk provides a reliable block storage for GCE VMs. This is exclusively for VMs. Disks are independent of compute engine VM. Compute engine VM will have an inbuilt compute engine VM. This is the extra add-on that we add, and even if the VM dies, the persistent disk remains. It's not ephemeral. The disks can be up to 64 TB in size. Persistent disks can have one writer and multiple reader, but it can always have just one writer at a time, but have multiple readers simultaneously. Supports both SSD and HDD storage options. I think you guys already are aware of what SSD and HDD. SSD offers best throughput for IO intensive applications. PD is available in 3 storage types: zonal, regional, and local. Right? You can attach persistent disks for zonal, regional, and local. So let's quickly get into a demo of how to create a bucket, how to store data into a bucket, how to explore with different options. Just give me 2 minutes. Let me log into the console. So I have logged into GCP Cloud Console. This is the navigation menu, and this is the project selector bar. Let's choose the project, my first project. Let's go to GCS. And here, let's create a bucket. Choose the most important thing. There are a couple of things you need to please pay attention to these features. The name should always be globally unique, because as soon as you create a bucket, GCP will provide you a bucket URL, and which is why the name you select should be globally unique. And if it isn't globally unique, you will get a pop-up saying you'll have to change the name of the bucket. Check this out. That bucket name is taken. Try another. Bucket 123. That bucket name is taken. Try another. Check this out. So this bucket name is available. So it should always be globally unique. What do you mean by globally unique? It should be unique across all the users across the globes who have created buckets. The name shouldn't intersect with any of them. It should be globally unique. Because as soon as you create a bucket, you will get a URL to access a bucket. Continue. This permanent choice defines the geographic placement of your data and affects cost, performance, and availability. These are the 3 metrics it affects depending upon the location type you choose. The first location is multi-regional. It provides highest availability across largest area, highest availability and lowest latency across 2 regions, and regions. For example, if you choose multi-region, right, you can choose all the regions that fall under Europe. If you choose US, you can choose all the regions that fall under US. If you choose Asia, you can choose all the multiple regions in Asia. Next, dual region is, you can select either if it's Netherlands or Finland, Tokyo or Osaka. It's basically the region, and region is a single region. US East 1. Let's go to our region. Asia South 1 is Mumbai. Asia South 2 is Delhi. Asia Southeast 1 is Singapore. Asia Southeast 2 is Jakarta. Let's choose region and select Asia South 1 Mumbai. Continue. And this is where the important thing comes into the storage class that I explained. Storage class sets cost for storage, retrieval and operations. Pick a default storage class based on how long you plan to store your data and how often it will be accessed. Standard, best for short-term storage and infrequently accessed data. Nearline, best for backups and data accessed less than a month. Cold line, best for disaster recovery and data access less than a quarter. Archive, best for long-term preservation of data accessed once in a year. So these are the 4 types of storage classes that's available. Let's choose standard and let's choose uniform. How you control. If it's uniform, it will have access to all the objects in the bucket by using bucket level permissions. This option becomes permanent after 90 days. This is specifically access to individual data types using fine grain means it specifies access to individual objects by using object level permissions in addition to bucket level permissions. Continue. You can add label for the type of data. Create. You can create a folder calling images. Go to image. Here you can upload any particular image. If you have uploaded a Snow White image, type image, form extension JPEG, creation time, storage class standard, public access no, this is not open to the internet, managed, and you have the download option. Click on 3 dots, you have download. You can also edit the metadata, you can edit permissions, you can copy, remove, rename, you can export this to PubSub, you can scan with data loss prevention. So this is how you create a bucket. You choose a storage class, you choose a location type, you choose a you choose a location type, you choose a storage class, storage type, you create folder inside a bucket, and you upload an image to the bucket. So again, every application is unique. It's never one size fits all. You have to take a judgment, you have to take a call based on the application you work on, based on the customer base of your application, right? It's every application is unique. Based on that application, it can be regional, or if you have multiple users, you are spread across different regions, then you can choose multi-region. If your application is accessed only by 2 separate regions, you can choose dual region. It's completely application context, right? Yep.
Yeah, got it. Thank you.
Pleasure. Let me close this demo and get back to the final touch up. So GCP services use cases, right? Product, you have Google Cloud Storage. What is that? Objects, the storage type, object storage. Persistent disk, block storage. Cloud file store, file storage, right? Key feature, scalable, durable, long-term storage. Use case, centralized storage for frequently and infrequently accessed files, right? Second, block storage. persistent disk. Is it what type of so this falls into block storage type. And it key feature, it's attached to GCVMs. Use case, dedicated attached storage for apps running in VMs based on HDD and STDs. Cloud file store, file system, NFS file share for GCVMs. NAS like shared file storage with standard Unix permissions, right? And also, I have to explain few things with respect to file storage. File storage is a fully managed network attached storage for compute engine and GKE instances. Its predictable price performance scales to hundreds of terabytes for performance workloads. Some of its key features are supports your highest performance workloads. FileStore offers low latency for file operations for workloads that are latency sensitive, like electronic design automation, media rendering, data analytics, or other metadata intensive applications. FileStore supports capacity up to 100 TB and throughout 25 GB per second and 720K IOPS with minimal variability. Expedite migration of enterprise application. Many enterprise applications are reliant on file semantics and capabilities. File stores enable migration to cloud without requiring you to rewrite most of your business critical applications, which accelerates and simplifies your migration. Full NFS v3 support is offered by Cloud File Store, which means File Store offers native compatibility with existing enterprise applications and supports any NFS v3 compliant client. Applications gain the benefit of features such as scale-out performance, hundreds of TBs of capacity, and file looking without the need to install or maintain any specified plugins or client-side performance. So these are the advantages of cloud file storage. It has NAS-like shared file storage with standard Unix permission. It's basically used for VMs and GKEs. So yeah, this is the deep dive of the major storage services inside in which you have liberty to choose the different location types, storage types, and also storage classes based on your application requirements. I hope you've got great amount of knowledge. There are a couple of modes remaining. Wrap up this great session.